So using laws of exponents, at the top, just a little bit down in the gray box, there are the three laws. The first law says that if you have an exponent, say n, and you are multiplying it by the same base with maybe another exponent, and I'm going to call it m, I think they have it written kind of similarly, the result in this first law is the sum of those two exponents. Again, it's the same base. Okay, the base is the same. So this could be x cubed times x squared. The end result is x to the fifth. Okay, which is the sum of 3 and 2. All right, numerically, 6 squared times 6 to the fourth. Simply put, it's 6 to the 6th. You might think, well, hurry up and multiply that 6 times 6, and that makes it 36, but that is not true, because then you're saying it's 36 to the 6th. Okay, and that's a completely different number than 6 to the 6th. Okay, that's the first law. The second law is if you have a monomial being governed by an exponent on the outside of a parentheses, then that means this is affected by this that many numbers of times. So it'll look like this: a to the m, b to the m. In simpler terms, like say x, y cubed, it becomes x cubed, y cubed. Or how about 3ab squared? Then each thing is affected by that. 3 squared, a squared, b squared. Okay, that's example 2, or law number 2. The third and final law is, what if you have a power on the inside being raised to yet another power? They call this scenario the power of a power. And they've got a to the m to the n power. The result is the product of those two powers. Okay, and this one is the most confusing for me, because this one and this one look very similar to me. All right? So x to the third to the second. So you're thinking, well, Mrs. Myers, the example above, you add those. But what is really being done is this x to the third is happening twice. Okay? So it's like saying xxx, xxx, which in the end is x to the 6th, not x to the 5th. All right? So the easiest way for me to think of this is whatever is happening in here, or whatever is indicated here, is done that many times. Okay? If it was a number, you'd square it, but these items, these powers, get done that many times. It's the best verb I can think of. Okay? There's a whole lot more definition below this, but I find that the examples speak better than the explanations do. So I'm going to go ahead and cruise into example 1. Now the way they explain these is using the laws. And if that helps you, great. If it doesn't help you, find a method that does. Find something that clicks for you. Okay? So to start with, example A, we've got 3x squared y cubed and 4x y squared. This literally means this monomial multiplied by this monomial. Okay? So you can use the first law, the multiplication law. Okay? I work these with the numbers first. -12. Since you're multiplying, you're going to add the exponents. X squared, x to the first, x cubed. Since you're multiplying, you're adding the exponents. Y cubed, y squared, y to the 5th. Okay? So this is law 1. Basic multiplication. Okay? This is law 1. Similar to basic multiplication. Alright? Letter B is st to the 4th to the 3rd power. Okay? The coefficient is 1, so 1 to the 3rd power is 1. S to the 3rd power is s cubed. T to the 4th to the 3rd power is the same thing as going t, which is T12. Okay? This item is being done 3 times, just like this item was done 3 times. Okay? Because this is on the outside of what's on the inside, you multiply that exponent by the exponents within. Okay? The easiest thing for me to remember is if there is an exponent on the outside of parentheses, it gets multiplied by the exponents within. Alright? S cubed, t to the 12th. Alright. Negative x cubed squared. Negative x cubed squared. So I've got, if I break this into a number, I've got -1 that is being squared, right? And I've got an x cubed that is being squared. So based on the law, if something is on the outside, it's multiplied by what's within. -1 squared, -1 times -1 is a +1. X cubed squared is x cubed, which is x to the 6th. You would just write x to the 6th, I'm sure. Okay? Example 2. What if you're faced with several of these scenarios where you have to determine what to do? And as you do this, you're going to have to look at each one and see what pattern it follows. Otherwise, you won't feel comfortable. Example 1, u times u squared to the 3rd power times u to the 5th. Let's focus on the middle piece. U squared to the 3rd power. That's 2 times 3, because you multiply it on the outside. Sorry, I lost my place there. So this 2 times 3 is u to the 6th. All of that multiplied by the other pieces, and you end up with u to the 6, 5, 11, and 12. U to the 12th. Okay? 2 times 3 is 6. Since it was on the outside, you multiply it by what's within. Okay, that's the first one. The second one in this bunch is a bunch of stuff within being cubed. Okay. I always start with the numbers. 3 cubed, 27. X to the 1, 3 times, that's x cubed. Y2 cubed, that's 6. Z3 to the 3, that's 9. 3, 6, 9. This should be your answer. Okay? If you have stuff within parentheses, the numbers get normally squared or cubed, but the exponents of the variables get multiplied by the exponent on the outside according to the rule. All right. Example 3. There's all very specific rules for each scenario. You've just got to decide which scenario fits. Okay, when you have something in front of a polynomial that is in parentheses, it's multiplication, right? And the rule for multiplication with exponents is you add them. Okay, so this is a 1 for a coefficient, this is a 1 for a coefficient. 3 times 1 is 3. T squared times t cubed, you add it, t5. Okay, that's the first piece. 3 times negative 2, negative 6. T squared, you add it. T4. 3 times 1 is positive 3. T2, T1 is t cubed. 3 times negative 4, negative 12. There is no variable here, so it's t squared. There's your answer. Okay? Example 4 is the trickiest of the ones you're going to have to do, and that's only the last handful of the assignment that will be in that batch. So, example 4, here we go. A2 to the k times a k to the 3. Now, unlike the multiplication law, when you are taking a power and raising it to another power that follows the parentheses, you multiply the exponents. So this first piece becomes a to the 2k. The second piece, and we're going to be multiplying here in a second, so I'm going to continue my parentheses. This piece becomes a to the 3k. Okay? So I've done the power to the power scenario. Now I'm left with a multiplication. All I have left is multiplication, and to multiply, you add your exponents. Okay? So power to a power, you multiply the exponents. Normal multiplication of exponents, you add them. Okay? That's 4a. B is xm minus n multiplied by xm plus n plus xn. This is very similar to example 3. We treated this like multiplication, and we're going to do the same thing here. Multiplying the same base, you add the exponents. X, m plus m is 2m. A negative n and a positive n cancels out. Okay? This other piece, same base, you add the exponents. X, m added to nothing is still m. N and a positive n disappears. Okay? X, 2m plus xm. You cannot combine these because these are not the same thing. This is being raised to the power of 2m. This is being raised to the power of m. So you can't combine that and say it's x to the 3m because that's not true. Okay? Example 4 is the trickiest part of this. Definitely the trickiest.